Hey there, everyone. Welcome back to another Mr. Oldenborg production of math. Yeah. We're going to take a second attempt at this, and I will have you know I ordered a stylus for my videos, so that way my fat fingers won't be killing straight lines, fat numbers, things like that. Give us a little more room in the future. So I'm excited. Hopefully you're excited. Let's get this started. We're going to find products of mixed numbers today, all right? It's exactly what we did in class. I have a problem. I have many problems, but this one is 7.5 times 2 3/4 because I need a part of a part with holes now. You might say, wait a minute. We were just taking parts of a part. What's with throwing with this loop of whole numbers? Well, it's not as bad as we think it's going to be. What we're going to have to do is we're going to have to take those holes and break them into parts, all right? We're actually going to end up with improper fractions, and then those parts of parts are going to be multiplied together and then brought back into another whole number, all right? Now, when I was young, 20 minutes ago, and your parents, our teachers would teach us things like this. First, you multiply the denominator times the whole number, and then you're going to add the numerator to it. And you know what that taught us? Nothing. Absolutely nothing. Aside from the fact that you'd multiply a denominator times a whole number and add a numerator to get a new numerator. Wow. Yeah, thanks for that. What that really means is, you know what? I have 7 holes. So I'm going to draw 7 holes. And then that little beautiful thing over here called the denominator says, hey, guess what? Each of these holes is broken into 2 pieces. So I'm going to go over here. I'm going to break each one into 2 pieces. Bam. Then, since I know what a numerator means, it means, hey, this is what's left over out of what each is broken into. I know I still have 1 out of 2 pieces to make that whole. So I have to add 1 more piece. There you go. Now, if I followed that sound math that we were taught as children, 2 times 7, which is 14, plus 1, which is 15, my new numerator would be 15 over 2. Now, if I wanted to know what that looked like, I'd go over to my picture, and guess what? I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 halves. Now I have some meaning. Now I understand why I'm multiplying and adding to get this improper fraction. What it's saying is, hey, I have 7 whole groups of 2's. And that's what this is, 7 groups of 2's. Plus an extra. And that's what this means. Now let's take a look at the 2 3/4. I'm going to follow the same rule. I'm going to multiply 4 times 2, which is 8. Add 3 for a nice, comfortable 11, because these are numbers we love to work with, right? It looks beautiful. I might say, you know what, Mr. O, hold on a second. Let me draw a picture. What do I have here? Well, I have 2 holes, don't I? Each of those holes is now broken into fourths. So let me do that. Then, Mr. O, I have 3 out of 4 left over. Okay? That's 4/4, Mr. Oldenborg. I know. Can always erase that little piece. There you go. Happy little eraser. Boom. And if I check my work, which I should always do, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 fourths. We're in good shape here. So now I got to do something ugly. I realize that I do not have any simplification that I can do. No numerator and denominator share a common factor. So I'm going to have to multiply these. It's terrible. But I got to do it. 11 times 15, we did in class, so I'm just going to throw up that it's 165. And 2 times 4 we know is 8. And I'm left with that improper fraction, which I know I'm not allowed to leave. So what am I going to do? Fractions are just division problems. So what I'm going to do is I'm going to take 8, and I'm going to change the color of my marker first so you're not confused. I'm going to take 8. I'm going to divide it into 165. I know that 8 won't go into 1 at all, but 8 will go into 16 twice evenly, won't it? Sure it will. Then I know that 8, and let's pay attention to this because this is a biggie right here. 8 goes into 5 0 times. This is where you guys make tons of mistakes. I need something in this place value. The only way to represent it is by asking the right question. How many times will 8 go into 5? Don't say it won't. How many means a number. It will go in 0 times. So I will write 0. And I have 5 left over. All right? That placeholder matters. You guys always end up putting 2 remainder 5 and forgetting about the place. Every digit of a quotient needs to be placed over a digit in the dividend. No blanks, nothing. Here we go. What do I have left? Well, I have 20 holes. And I have, I'm running out of room. 5 out of 8 left. So, what am I looking at? I'm looking at that 7.5 times 2 3/4 is going to be 20 5/8. Even though that 20 does not look very good, it looks more like a 26, and I would probably say something to you about it. Remember, last day of fat fingers. I'm sorry. Let's take a look at the next problem. Actually, no, let's not look at the next problem. Let's look at a surface area model for a minute. Let's look at that same problem. That same problem was 7.5 times 2 3/4. And what this does is this separates your whole number from your fraction. I'm not going to have you responsible for this. I just want you to be able to see what's going on here because there's a lot of extra work that has to go on, and I don't want to spend much time on it because you're not going to use this. What we're going to do here is we're going to multiply everything separately and then bring it together. So in one spot, we're going to take 7 and we're going to multiply it by 2 right here. All right? So we have 7 times 2, which equals 14. Then what we're going to do is we're going to take 1/2 and multiply it by 2. And we're going to put that underneath the half. 1/2 times 2 is 1. Then I'm going to take 7 and I'm going to multiply it by the 3/4. All right, it's going to go right here where the 2 intersect. And 7 times 3/4 is, oh, I got to do this in my head now. Way to be prepared. 21 over 4. 21 over 4, we'll just leave as 21 over 4 because we're not going to go through the whole thing. We would obviously have to turn that into 5 1/4. There, I did it anyway. I might as well write it. And finally, my last one, I'm going to multiply 1/2 by a 3/4, bring it down here. It's 3/8. Now, I have 4 different values. 1, 2, 3, 4. All part of this whole. I have to add them together. And this is where it gets messy. Like, it was nice for a little bit. But what do I notice here? Well, it's not that easy to add it, is it? Of course not, Mr. O. Why? Because you just said so. I have uncommon denominators. So sure, while I could do 14, 15, 20, hey, 20, I remember that, I still have to add 1/4 plus 3/8. And when I do that, you know, obviously, they're not the worst numbers. I'll get 8 here, which will make it 2/8. 2/8 plus 3/8 is 5/8. I'm still going to end up with my 20 and 5/8. But as you can see, one of the drawbacks to doing this is that I might have to work with common denominators. Whereas here, I didn't have to worry about any of that. All I had to do was make the improper fraction a mixed number. Let's take one more look at one other problem, because I just want to talk about simplifying and the power of it for a moment. Here again, we had the 7.5. Boop. And then we multiplied it by 3 1/3. And then you might say, oh, 3 1/3. How do I draw me some thirds? Well, first you'd worry about drawing your 3. Then we'll draw thirds. And you could try to break it up any way you want. Again, if you have trouble drawing thirds without, just by itself, I could have drawn that third by itself. Draw the full thing. And then just erase like this. All right? You're totally allowed to do that. All right. So what do I have? Well, I have 7.5 times 3/3. If I go back and do that algorithm, I have multiplying and adding. 2 times 7 is 14, plus 1 is 15 over 2. Times, now I have 3 times 3, which is 9, plus 1, which is 10, over 3. I'm going to stop here a minute. Because right now, if I look and I multiply it across, I'm going to get 150 over 6. Then I'm going to have to divide 6 into 150. And while that's so doable, it's also annoying because they're big numbers. When I look at my problem right now, I'm noticing one thing. I'm noticing that I have numbers that share common factors. I can divide by these numbers. If I look over here, I have a 2 and a 10. They share a common factor of 2. A lot of kids say they share a common factor of 5 because they do 2 divided into 10, and that's 5. And hey, that's great because that's going to end up here. But the big thing is I'm really dividing both by 2. 2 goes into 2 once, 2 goes into 10 5 times. Now I find out that I also have 3 and 15 which share a common factor of 3. So I'm going to divide 3 by 3 and get 1. I'm going to divide 15 by 3. I'm going to get 5. Now when I multiply across, I'm doing 5 times 5, which is 25. And I'm doing 1 times 1, which is 1, which is 25. Now, if you ask me, that's a lot nicer to do than 150 divided by 6. So always look to simplify if you can. And the only way you're going to know that is if you take a second and you really know your multiplication facts well, forwards and backwards, because that's what's going to help. You've just completed lesson 8-7. We can call it World 8-7. Let's have a little Mario victory music for this bad boy. See you next time on these one-shot videos.